So today, the second lecture of D and F block elements. The last lecture we have done 10 questions. Now, question number 11. Question is complete the following chemical equations. And this question came in All India 2011. The question is, we have an equation that is MnO4 negative plus S2O3 2 negative plus H2O aqueous liquid. So we have to complete this equation. So see, MnO4 negative, that is permanganate ion, is an oxidizing agent. So it oxidizes S2O3 2 negative into thiosulfate into sulfate. So see, we will write two equations. First one is MnO4 negative aqueous. It will give Mn2 plus. Every time when you have MnO4 negative and medium is acidic, say thiosulfate gives sulfate in water, so that becomes sulfuric acid, means medium is acidic. Though H plus ion is not written here, but it is understood that it is an acidic medium, and in an acidic medium MnO4 negative will give Mn2 plus. That you should keep in mind in acidic medium. MnO4 negative will give Mn2 plus. Just balance it. How do we balance in acidic medium? We have to add H2O to the side deficient of oxygen. Just note down that add H2O to the side deficient of oxygen. So there are 4 oxygen on the left side, no oxygen on the right side. So we add 4 H2O on the right side and double number of H plus ion to the opposite side. Double number of H plus ions to the opposite side. So total charge on the left side is 8 plus and minus 1, 7 positive. On the right side, total charge is 2 plus. So to balance the charge, we have to add 5 electrons. So keep in mind n factor of KMnO4 in acidic medium is 5. Now second part, S2O3 2 negative, second half of the reaction. S2O3 2 negative, that will give SO4 2 negative. So what we do, we balance. First rule is, that is in class 11, balance the atoms other than hydrogen and oxygen. So other than hydrogen or oxygen, there is sulfur. So we write 2 on the right side, so that sulfur on both sides are balanced. Now take a look the number of oxygens. On the left side there are 3 oxygens. On the right side there are 8 oxygens. 3 oxygens on the left side, 8 oxygens on the right side. So we will write, or we can say we will add 5 H2O on the left side. Now oxygens are balanced and double number of H plus ion to the opposite side. So 10 H plus ion. Now electron. See, on the left side there is 2 negative charge. Total net negative charge on the left side is 2, minus 2. On the right side it is 4 negative and 10 positive, means 6 positive. So we add 8 electrons, so that net charge is 2 negative on the right side as well, 4 negative, 8 negative, total 12 negative and 10 positive, so minus 2. Now multiply first equation by 8 and second equation by 5. Tell me what is the answer. Cancel out the common like water, H plus ions, and tell me what is the answer. Did you understand? So tell me. Just add them. So 8 MnO4 2 negative. I let you know how to balance in basic medium as well, okay? Because water is written on the left side. So let us see. 8 MnO4 negative plus 5 S2O3 2 negative plus now water 25 water on the left side and 8 for the 32 water on the right side, means water comes on the right side. That means medium should be basic, because in acidic medium water is on the left side, but in our question water is on the left side, but in net equation if we balance it in acidic medium, then water comes out to be in the right side. Just balance first in acidic medium, then I let you know how to balance in the basic medium. Okay, so 25 and 32, so it should be on the right side. Then come to H plus ion. 8 is the 64, 64 H plus on the left side and 50 H plus ion on the right side. So net is 14 H plus. Then come to next part, that is 8 Mn2 plus 10 SO4 2 negative plus 32 minus 25 plus 7 H2. So this is the balanced equation in the acidic medium. But say when we balance this equation in acidic medium, H plus ions are there on the left side and the water is on the right side. But in our equation, water is on the left side. That means this equation is not balanced in acidic medium. But anyhow, at the end, what we see, if we balance in acidic medium, total charge on the left side should be equal to total charge on the right side. So see, minus 8, minus 10, 5 to the 10, minus 10, minus 18 and plus 14 is total minus 4 charge on the left side. Come to this side, 16 positive and minus 20 means minus 4 on the right side. So that means it is balanced in the acidic medium now. Now let us do in the basic medium. So in basic medium, keep in mind in basic medium or means weakly basic medium or neutral medium. In weakly basic medium or neutral medium, MnO4 negative ion will give MnO2. MnO4 negative will give MnO2. So see, atoms other than hydrogen and oxygen are balanced. One manganese on both sides, right? Now add H2O to the side. See, in acidic medium, we add H2O to the side deficient of oxygen. But this time, in basic medium, add H2O to the side excess of oxygen. Okay. So see, on the right side, there are 4 oxygens. On the left side, 2. So excess of oxygen are 2 on the left side. So 2H2O and double number of OH negative ion to the opposite side. Or OH negative. Now add the electrons to balance the charge. On the left side there is -1 charge, on the right side there is -4 charge. So we add 3 electrons. So n factor of KMnO4 in basic medium or neutral medium is 3. Now next, S2O3 2 negative. Now S2O3 2 negative gives SO4 2 negative. So now first balance the atoms other than hydrogen and oxygen. So 2 sulfur, 2 sulfur. Now on the right side there are 8 oxygens. On the left side there are 3 oxygens. So now add 5H2O. We add water on the side excess of oxygen, and there are 5 oxygen in excess on the right side, and double number of OH negative ions on the opposite side. Double number of OH negative ions on the opposite side. So total negative charge on the right side, left side, it is 12 negative. On the right side, 4 negative. That means we have to add how many electrons? 12 negative and 4 negative. So we have to add 8 negative charges, means 8 electrons. So now add the equations by balancing the electrons. Means number of electrons gained should be equal to number of electrons lost. So we multiply first equation by 8 and the second equation by 3. So write it, 8 MnO4 negative plus 3. First of all, write those ions which are oxidized and reduced. Okay, best way to write is first of all write those ions which are oxidized and reduced. So MnO4 negative ion is reduced to MnO2 in basic medium or neutral medium. Okay, and S2O3 thiosulfate ion is oxidized to sulfate ion. Now see, on the left side there are 16 water molecules, and on the right side 5 3s are 15 water molecules. So we add 1 water molecule, means now it's okay because water is appearing on the left side. Now come to OH negative. On the left side there are 30 OH negative. On the right side there are 8 4s are 32 OH negatives. OH negative ion should be on the right side. Okay. So this one 8 MnO4 negative plus 3 S2O 3 2 negative aqueous plus water to give 8 MnO2 solid plus 6 SO4 2 negative aqueous. Water we have already balanced, and OH negative ion 30 on the left side, 32 on the right side. So 2 OH negative ion aqueous. So this is the final balanced chemical equation. That is the redox reaction actually, where MnO4 negative ion act as an oxidizing agent and S2O3 2 negative thiosulfate ion act as a reducing agent, right? Because MnO4 negative ion gains electrons and S2O3 2 negative ion loses electrons. Okay, so this is first equation. So this one is the right equation that we have to balance in basic medium. Second is Cr2O7 2 negative Fe2 plus H plus. And at the same time there is no confusion at all for dichromate ion, because dichromate ion act as an oxidizing agent only in acidic medium. Keep in mind. But KMnO4 that can act as an oxidizing agent in acidic medium, basic medium, neutral medium, all the mediums. That's why we should look at MnO4 negative ion, in which medium this equation should be balanced. But if H plus ions are given, then there is no question. Medium is acidic. If OH negative ion are given on the left side, again there is no question. Basic medium is there. But here water is given. So keep in mind, water means neutral medium. So we should balance in acidic, in basic or neutral medium. Okay. Okay. Next question is Cr2O7 2 negative. Cr2O7 2 negative aqueous plus Fa 2 plus aqueous plus H plus aqueous. So first of all, Cr2O7 2 negative aqueous, it will give Cr3 plus. Cr2O7 2 negative ion always gives Cr3 plus. So balance it in acidic medium. So first rule is balance the atoms other than hydrogen and oxygen. So first of all, you should keep in mind whenever dichromate is there, dichromate is always reduced to Cr3 plus. That's it. Now balance the atoms other than hydrogen and oxygen. Chromium is there. On the left side 2 chromium, on the right side only 1. So we multiplied by 2. Now we left with oxygens. On the left side there are 7 oxygens. On the right side there is no oxygen. So we should add 7 water molecules on the right side and double number of H plus ions to the opposite side. Double number of H plus ions to the opposite side. So on the left side there are total net positive charges 12. On the right side net positive charge is 6. So we have to add 6 electrons to balance the charge. In this part, always keep in mind that chromium, first of all, we have to balance chromium. Sometimes students do this mistake. What they do, dichromate, there are two chromium, but on the right side there is only one chromium. They balance the equation, whole equation right here 9 instead of 6, because chromium they take it as 1 only. So always keep in mind that chromium on the both side should be balanced before adding water, before balancing oxygen or hydrogen. Okay, so this is the balanced equation. Next is Fe2 plus. So Fe2 plus, it is oxidized by dichromate to Fe3 plus. So balance the charge to 1 electron. We multiplied by 6, 1 with dichromate. Cr2O7 2 negative aqueous. 6 Fe2 plus aqueous. 14H plus aqueous. 2 Cr3 plus aqueous. 6 Fe3 plus aqueous, and 7 H2O liquid. That's it. So the method I have adopted here to balance the equations or to write the balanced redox reaction, this is called ion electron method. Ion electron method or partial equation method. Okay, partial equation method or half reaction method to balance the equation. Now let us do by using oxidation number method. Okay, let's do by using that. It is MnO4 negative aqueous plus S2O3 2 negative aqueous plus H2O liquid to give MnO2, right? Because it is in basic medium. So MnO4 negative will give MnO2. S2O3 2 negative will give SO4 2 negative. Okay. Now, what is the oxidation number of manganese? In MnO4 negative, what is the oxidation number of manganese? How do we calculate? Take X, manganese as X, oxygen minus 2. So it is X minus 4 to the 8 equal to minus 1. That implies X equal to plus 7. So in MnO4 negative, manganese is plus 7. Now in S2O3 2 negative, X minus 2, 2X minus 6 equal to minus 2, 2X equal to plus 4, X is equal to plus 2. So in S2O4 O3 2 negative, sulfur has plus 2 oxidation state. In MnO2, it is plus 4. Because X minus 4 equal to 0. See, MnO2, how do we calculate? Its charge is 0. So X minus 4 equal to 0. X equal to plus 4, SO4 2 negative, X minus 2. So X minus 8 equal to minus 2, X equal to plus 6. So first of all, in this case of even, this is the oxidation number method, okay? Balance the atoms other than hydrogen and oxygen. See, manganese 1, manganese 1, sulfur 2, sulfur 2. Now, balance, what is the change in oxidation number of manganese? Plus 7 to plus 4. There is a change of 3. Oxidation number is decreased by 3. In case of sulfur, plus 2 to plus 6. Increase by 4 per sulfur, but there are 2 sulfurs. So total increase is 3. See, total increase by 8. Per sulfur increase is of 4, but there are 2 sulfur. So total increase in oxidation number is 8. Oxidation number increased by 8 and oxidation number decreased by 3. So we have to balance, equalize it. Increase in oxidation number should be equal to decrease in oxidation number. So it should be multiplied by 8 and this is multiplied by 3. So total increase in oxidation number becomes equal to total decrease in oxidation number. So 8, 8, 8, 3 and into 3. So now we will write it in the next section, that is 8 MnO4 negative plus 3 S2O3 2 negative H2O liquid to give 8 Mn2 plus aqueous plus 6 SO4 2 negative aqueous. Now come to the oxygens. Leave aside the water. The one which are oxidized and reduced, you have to count oxygens and hydrogens in them. See, total number of oxygens, there is no hydrogen in them. Okay, so oxygens on left side, this is left side and this is right side. So 8 4s are 32 plus 3 3s are 9. 41 oxygen on the left side and 24 oxygens on the right side. So what is the difference? Difference is 17. Okay. Oh, sorry. It was not Mn. It was MnO2. It is not Mn2 plus. It was MnO2. So total oxygen on the right side, 6 4s are 24, 8 2s are 16. 24 plus 16, 40. 40 oxygen on the right side. So means difference is of 1 only. So 1 water and double number of OH negative ions. That's it. So this is balanced chemical equation in basic medium. Now final check is to verify, just say the total charge on the left side, sorry, just on the left side should be equal to total charge on the right side. See 8 negative, 6 negative, minus 14, 12 negative, 2 negative, minus 14. That means okay, this equation is balanced. Second one, Cr2O7 2 negative aqueous plus Fa2 plus aqueous to give Cr3 plus aqueous plus Fa3 plus aqueous. So chromium 1, 2, chromium 2. First of all, balance the atoms other than hydrogen and oxygen. Now, what is the oxidation number of chromium in dichromatin? X minus 2, that is 2x minus 14 equal to minus 2. So 2x equal to plus 12. X is equal to plus 10. Sorry, x is equal to plus 6 because it is 2x equal to plus 12. So oxidation number of chromium in dichromatin is plus 6. Iron, it is iron, so charge on the iron is taken as its oxidation number. Here it is plus 3, Fe3 plus, again plus 3. So see the change, plus 6 to plus 3. There is a change of 3 for per chromium, plus 6 to plus 3, decrease in oxidation number by 3. But there are 2 chromium, so decrease in oxidation number by 6. Now come to Fe2 plus, increase in oxidation number by 1. So decrease and increase should be equal. So we multiplied by 6. So 6 Fe2 plus 6 Fa3 plus. 6 Fa2 plus 6 Fa3 plus. So see the total charge on the, now it's okay. Now we write it separately, okay. Cr2O7 2 negative, aqueous, six Fe2 plus, aqueous, 2 Cr3 plus, aqueous plus 6 Fa3 plus aqueous. Now medium is acidic, so balance the oxygen atoms, add H2O to the side, excess of oxygen, and double number of H plus ion to the opposite side. That's it. It is balanced equation. See the charge, 12 plus 14, 12 minus 2, 10 plus 14 plus 24 on this side, 6 positive and 18 positive, means 24 positive. That means charge on both sides is equal, and that's it. So these are the two methods to balance the equation, and there is always a one question at least of 2 marks to balance the equation. That's why I took so much time to show you, to explain how to balance the equation. Yes, beta. Did you understand? Okay. So next question is, copper 1 ion is not stable in an aqueous solution. We have already done this equation, this question, that copper 1 plus aqueous, it always disproportionate in aqueous solution like this, because copper 2 plus aqueous is more stable than copper 1 plus aqueous. Why is it so? Because when copper 1 plus is converted into copper 2 plus, so huge amount of energy, second ionization enthalpy, and 3d10 to 3d9 it is converted. So second ionization enthalpy is high enough, but when copper 1 plus gaseous is converted into copper 2 plus gaseous and in water, it undergoes hydration. So hydration enthalpy of copper 2 plus is very large, and that's why copper 2 plus aqueous, hydration enthalpy of copper 2 plus, magnitude of the hydration enthalpy of copper 2 plus is very large than the second ionization enthalpy of copper. Means to convert copper 1 plus to copper 2 plus, energy required is less than energy released when copper 2 plus is hydrated, and that is the reason that I have explained already the previous lecture. See, copper 2 plus is much more stable than copper 1 plus aqueous, because although second ionization enthalpy of copper is large, but hydration enthalpy of copper 2 plus is much more negative than that for copper 1 plus, and it more than compensates for the second ionization enthalpy of copper. And that's why many copper 1 compounds are unstable in aqueous solution and undergo disproportionation as follows. Next question. Unlike chromium 3 plus, Mn2 plus, Fe3 plus, and the subsequent other M2 plus ions of the 3D series of elements, the 4D and the 5D series metals generally do not form stable cationic species. So what is the reason? Actually 4D and in 5D series, metallic bonding becomes stronger, because in them electrons are loosely held, more loose, and therefore they can participate in bonding more than in 3D series. So their intermetallic bonding, their metallic bonding is strong enough than that of 3D series, and because of that their enthalpy of atomization is high. And at the same time, because as we go down the group, due to the participation of F block elements which have poor shielding, their size decreases, or size is almost same as that of 3D, and their size is almost same as that of 3D series, and that's why their ionization enthalpy is very high, because nuclear charge is increasing but size is not increasing as expected, and that's why their enthalpy of atomization is high as well as their ionization enthalpy is high, and their melting and boiling point is also higher than the first trine series, and that's why 4D and 5D series metal do not form stable cationic species. Next, explain giving a suitable reason. Transition metals and their compounds are generally found to be good catalysts. Already we have done it. First reason is due to the presence of unpaired electrons. It is already written. Second reason is variable oxidation state. Third reason is they provide surface area. Fourth reason is they can form complexes. So catalytic properties of transition metals are due to the presence of unpaired electrons in their incomplete d orbitals. They have variable oxidation states. That's also the point in favor of catalytic nature. They provide surface area like in hydrogenation reactions, and they can form complexes. So that's why they are good catalysts. Metal-metal bonding is more frequent. Just now we have done. The metal-metal bonding is more frequent for the 4D and 5D series of transition metals than that for the 3D series. So reason is this one. These have their electrons of outermost shell at a greater distance from the nucleus, and therefore they are more free to be shared. They are more free to be involved in bonding. So their metallic bonding is strong. Just now we have done that. As we go down the group, some but size is almost same, but because nuclear charge is increasing, electrons are, say, in the 3D series, this is 3D, 4D, 5D. This is the nucleus. Okay, so from the nucleus, 3D is closer, 4D is away, 5D is farther. Okay, so that's why 4D and 5D electrons are more easily available for metallic bonding. They are more easily participate in bonding, and that's why metal-metal bonding is more frequent in 4D and 5D series. Transition metals and their compounds generally exhibit a paramagnetic behavior. Why the compounds or elements are paramagnetic? Due to the presence of unpaired electrons. And most of the transition metals and their compounds have unpaired electrons. That's why, so because of the presence of unpaired electrons in their d subshell in an atomic and ionic state, they behave as paramagnetic. Okay, they show paramagnetic behavior. Chemistry of actinoids is not so smooth as that of lanthanoids. See, in actinoids, I already explained that in actinoids there is a filling of 5D, 6F and 7S. In lanthanoid there is a filling of 4D, 5F and 6S, right? Five F and 6F, 4F or 5. Sorry. In lanthanoid, there is a filling of 4F, 5D and 6S. In actinoids, there is a filling of 5F, 6D and 7S. So energy difference between 5F, 6D and 7S very less. Their energy is very close to each other, and that's why in actinoids all of them, that is 5F, 6D and 7S, are participating in bond formation, and that's why they can show wide variety of oxidation states ranging from +3 to +7. But in lanthanoid, because the difference is large enough, and that's why they can show oxidation state of +3, +2 and +4 only. They show +2, +3 and +4. Lanthanoid show limited number of oxidation states It is plus 2, plus 3 and plus 4, and out of which plus 3 is most common because of say the large energy gap between 4F and 5D subshells. But actinoids also show stable oxidation state of plus 3, but show a number of oxidation state plus 4, plus 5, plus 6, plus 7 due to the small energy difference between 5F, 6D and 7S subshells. Next again question, complete the following chemical equations. Acidic medium Cr2O7 2 negative. Now I'm not taking more time, just see Cr2O7 negative will give Cr3 plus 2 electron plus 7H2O plus 14H plus 6 electron. This equation you have to keep in mind. Next is I negative. I negative will give I2 2 plus 2 electron. So just balance it, just multiply it by 3. So it is Cr2O7 2 negative aqueous 6 I negative aqueous 14 H plus aqueous to give 2 Cr3 plus aqueous plus 3 I2 solid plus 7 H2O liquid. That's it. Just to recheck, to re-verify, just look at the charges. 6 negative, 2 negative, 8 negative, 14 positive, total 6 positive. On the right side 2 3 is 6 positive. That's it. Next part, this is first part. Now second part, again acidic medium. In acidic medium, MnO4 negative ion will give Mn2 plus 4H2O plus 8H plus 5 electron. NO2 negative aqueous to give, it will give NO3 negative aqueous. Nitrite gives nitrate ion. So add H2O to the side deficient of oxygen. Double number of H plus ion to the opposite side. So total 2 electrons on the right side. So multiplied by 5, multiplied it by 2. So net equation is, I will write here only, 2 MnO4 negative plus 5 NO3 negative sorry, on the left side 2 MnO4 negative, 5 NO2 negative is 5, okay, and how many H plus ion? 16 H plus 10, so 6 H plus, 2 MnO4 negative, 5 NO2 negative, 6 H plus, and on the right side 2 Mn2 plus aqueous, 5 NO3 negative aqueous, and water 8 H2O liquid. I think it is balanced now. Yes, it is balanced. See, the to verify 2 MnO4 negative minus 2, 5 NO2 negative minus 5, minus 2 minus 5, minus 7 plus 6. So total minus 1 charge on the left side, 4 positive, 5 negative. minus 1 on the right side. So it is balanced. Is 2 MnO4 negative. I will write here also 2 MnO4 negative plus 5 NO2 negative plus 6 H plus to give 2 Mn2 plus 5 NO3 negative plus 8 H2O. Oh, sorry, not 8 H2O. 5 on this side, 8 on other side. So total 3 H2O. 3 H2O liquid. So balancing, is it clear to you? Yes, beta. Any doubt in balancing? Okay. Next, enthalpies of atomization of transition metals are quite high. Same reason, because they have large number of unpaired electrons, so metallic bonding is strong. See, in transition elements, there are large number of unpaired electrons in their atoms. Thus, they have a stronger interatomic interaction, that is strong metallic bonding, and thereby stronger bonding between the atoms, and due to this, they have high enthalpy of atomization. So, in one sentence, you can write simply, due to the presence of large number of unpaired electrons, they have strong metallic bonding. That's it. Because of that, they have high enthalpies of atomization, they have high melting point, they have high boiling point. Next, transition metals and their compound, many of their compounds act as good catalysts. Same answer. See, here first, because of the availability of d orbitals, they can easily form intermediate products which are activated, and sizes of the transition metal atoms and ions are also favorable for transition metal complex formation. I have written already why they are acting as catalyst, due to the presence of unpaired electrons in their partially filled d orbitals, due to the presence of variable oxidation state. Due to the variable oxidation state, they show variable oxidation state, they provide surface area for the reaction to take place, and at the same time they can form complex. That's why they are good catalysts. Next, again we have to balance it. Cr2O72 negative plus 14H plus 6 electron to give 2Cr3 plus 7H2O. This equation you have to keep in mind. SO3 negative will give SO4 2 negative. You can balance by oxidation number method. There is no harm. But I love to do it by half reaction method, ion electron method. That's why I'm doing like this. Otherwise, I have already shown you, you can balance by ion electron method or oxidation number method. There is nothing written here. You have to complete the equation. Simple. SO3 negative sulfite gives sulfate. So add H2 because medium is here acidic only, because dichromate is there, and dichromate always act as an oxidizing agent in acidic medium only. So add H2O to the side deficient of oxygen and double number of H plus ion to the opposite side. 2 negative, 2 negative balance, and we have to add 2 electron to balance the, sorry. Yes, we have to add 2 electrons. Yes. So we have to multiply it by 3 only. So it becomes Cr2O7 2 negative aqueous plus 3SO3 2 negative aqueous plus, what about H plus ion? 6H plus on the right side, 14 on the other side. So 8H plus, so it give 2Cr3 plus 3SO4 2 negative aqueous plus water. So 4H2 because 3H2 on the left side, 7H2 on the right side. So 4H2. Okay, now re-verify. Just see the charge. 2 negative, 6 negative, 8 negative, 8 positive, 0 charge. 6 positive, 6 negative, 0 charge. That's it. Next is MnO4 negative, H2S plus H plus. So see MnO4 negative, 8H plus, 5 electron, Mn2 plus aqueous plus 4H2. This equation you have to remember. Or if you don't want to remember, just see MnO4 negative give Mn2 plus, add H2 to the side, deficient of oxygen, that is 4, double number of H plus ion, that is 8, and whereas the charge by adding electron, that is 5. That's it. Now H2S gives sulfur. H2S is oxidized to sulfur. So add 2H plus ion to balance the hydrogens and 2 electrons. We multiply first equation by 5 and second equation by 5 and first equation by 2 to balance the electrons. So it is 2 MnO4 negative aqueous, 5 H2S plus 10 H plus ion on the right side, 16 H plus ion on the left side. So 6H plus to give 2 Mn2 plus aqueous plus 5 sulfur plus 8 H2O liquid. So just see the charge. 2 negative, 6 positive, 4 positive, 2 to the 4 positive. That's it. So this is the equation. Next, which metal in the first Trigon series exhibit +1 oxidation state? That is only copper. Except copper, no other metal will show +1 oxidation state. Okay, copper exhibit +1 oxidation state. Why is it so? Because if you see the electronic configuration of copper, it is 3d10 4s1. It has exceptional electronic configuration due to fully filled d orbital. So after losing one electron, it acquires fully filled d orbital, and that's why it can easily lose 4s1 electron to give stable 3d10 configuration, pseudo noble gas configuration. Next, which of the following cations are colored in aqueous solution? So say ions are colored having unpaired d electrons because of dd transition. So in the first case, in the first lecture, we have done that d orbitals split into T2G and EJ in octahedral field. In octahedral complex, d orbital split into two parts, that is T2G and EG. Degeneracy is removed and T2G is triply degenerate, EG is doubly degenerate. And if there are unpaired electron, there is DD transition that takes place in the visible region, and that's why we can see the complementary color. Okay, so just look at the ions, see whether they have unpaired electron or not. If they have unpaired electron, they are colored. If they don't have unpaired electron, they are colorless, because in that case there is no DD transition. If it is D0 or D10, then they are white, or we can say colorless. In chemistry language, we call them as colorless. See, scandium 3 plus, scandium is 3D1 4s2. So after losing 3 electrons, scandium 3 plus has D0, no unpaired electron. Vanadium 23, 3D3 4s2. So after losing 3 electrons, it is 3D2. So there are 2 unpaired electrons. So that means it is colored. Titanium, it is 22, 3D2 4s2. So titanium 4 plus, no unpaired electron. Mn, manganese is 3D5 4s2. Mn2 plus, it is 3D5, so it has 5 unpaired electrons. That means vanadium 3 plus and Mn2 plus has unpaired electron, that's why they are colored. See, vanadium 3 plus and Mn2 plus are colored in their aqueous solution due to the presence of unpaired electrons, because they can undergo DD transition. There is DD transition. Okay, what is lengthened contraction and what are its two consequences? Very, very important question. You will definitely get the balancing of chemical equation of 2 marks. Okay, and second, this question, very, very expected question for every year. What is lengthened contraction and its consequences? Sometimes it is asked as cause. So say lengthened contraction means steady decrease. Definition we have done. Its cause also we have done due to the imperfect shielding of 4f electrons. So say what is lengthened contraction? It is steady decrease in size. Okay, steady decrease in atomic and ionic radii with increasing atomic number. Okay, the overall decrease in atomic and ionic radii with increasing atomic number is known as lengthenoid contraction. See, in going from lanthanum to lutetium, in lanthanoid series, the size of the ion decreases, and this decrease in size in the lanthanoid series is known as lanthanoid contraction. And it is arising due to, as I have already said, imperfect shielding of one 4f electron by another present in the same subshell. Imperfect shielding, because shielding of F is poorer. What is the order? F, shielding of F is minimum, then it is D, then it is P, and then it is S. Means maximum shielding is provided by S electrons, then P, then D, then F. So what is the consequence of this? See, first is like zirconium and hafnium, niobium and tantalum. Niobium is Nb. So zirconium to mercury, see it is written zirconium to mercury and hafnium to zirconium to cadmium and hafnium to mercury, they in the same group they have almost same charge. Like most of the question is zirconium and hafnium have almost same size. So question is why? So you should write due to lengthenoid contraction. Due to lengthened contraction, this 4-day series and 5-day series, they have almost same size. Means second tranche series and third tranche series elements have almost same size due to lengthened contraction. See, due to lengthened contraction, size of the elements which follow hafnium to mercury are almost similar to size of the elements of previous row, that is zirconium to cadmium, and hence these are difficult to separate because they have almost same size, so they have almost similar properties, and due to say small change in atomic radii, the chemical properties of lanthanoids, they are also very similar to, due to which separation of lanthanoid becomes very difficult. So first consequence is that second and third tranche series elements of the corresponding group are similar in size, that is due to lengthened contraction. Second, because there is a steady decrease in size, and that's why their properties among lanthanoid, their properties are almost similar, and therefore they are difficult to separate. Second is basicity difference. See, metal, oxygen, hydrogen. If metal is large in size, this bond breaking is easier. So OH negative ion we get easily, so that become more basic. And this, if this metal is small, then what happens? This bond becomes strong, so it is difficult to break, so it becomes less basic. So that means as we go along the lengthened series, size decreases, and that's why their basic character decreases. Basic character of their hydroxides decreases. See, due to lengthened contraction, size decreases. So covalent character increases, obviously, and therefore basic character of hydroxide also decreases. This covalent character increases, we apply Fezan's rule that small size of cation favors covalent character, because if size of the cation is small, it has high polarizing power, and that's why it is more covalent. Their compounds are more covalent. That's why lanthanum hydroxide is most basic, lutetium hydroxide is least basic, because along the lanthanoid series size decreases. The one which has large size is more basic. So in the start there is lanthanum, so that lanthanum hydroxide is most basic, and as we go along the series, size decreases. Lutetium has a minimum size, and that's why its hydroxide is least basic. So these are the consequences of lengthened contraction. Very, very important question. Last question of the day. Assign a reason for each of the following observations. Transition metals with the exception of zinc, cadmium and mercury are hard and have high melting and boiling point because they have large number of unpaired electrons. That's why their metallic bonding is strong, and that's why their enthalpy of atomization is high. Simply write because of the stronger metallic bonding due to the presence of large number of unpaired electrons, to the presence of large number of unpaired electrons. This is written as, this is hard, okay. Next, ionization enthalpies in the first series of the transition elements are found to be very irregularly. Reason is due to the irregularities in the enthalpies of atomization, due to the irregularities in the electronic configuration, because there are exceptions. Exactly half filled, fully filled, these configurations are there, and that's why there is irregularity in the ionization enthalpies. Due to irregularities in the electronic configuration, there is irregularities in the enthalpies of atomization, and hence there is irregularity in the ionization enthalpies. That's it. So that's all. Yes, beta, any doubt up to this? Okay, then thank you. So that's it. This is all. Smith Patel, okay, preparing for GSET and net. So after it is get a job of assistant. Yes, Smith, you will get the job, but just prepare well, because there is exams even after doing GSET. You will crack the exam. Okay, there. So thank you so much to all of you. You people, I'm balanced. I'm blessed to have all of you to be with me. Just support my channel, share with your friends, because the time to crack various exams, and in this channel I will help you to get each and everything of NCERT, that is its concept, its examples, in text questions, exercise questions, and at the same time NEET and JEE questions. And this is all free of cost. Just grab this opportunity. At the same time, share my channel with your friends, so that our community will grow, and I will do more than I'm doing right now. So it is responsibility of all of you who are watching my videos, that you should share with your friends, classmates, and in your community groups. Thank you so much. Support my channel and me. Have a nice day. Bye bye.